Today, I'm going to tell you guys a story about a novel. A noble in ancient times is actually just a very rich person who actually have royalty status. Now, this noble happened to be a very lonely man. He stays alone by himself, okay, in a castle, all alone by himself. And because he is all alone by himself, he will always just float around the castle as if he's a guest. And that being the case, okay, students, if you are getting me, you will know that I'm talking about group 8, okay? Or sometimes known as your group 0, and they are made of noble gases. Well, noble gases are monatomic atoms, and what happens is, right, they will exist as gas at room temperature. Because they are gases at room temperature, you should be able to figure out that they have generally very low melting point and boiling point. And these are their physical properties. Now, if it helps you, share with you a bit more about this noble. Now, this noble can't swim, okay? He can't swim. So, that being the case, right, that would hopefully help you remember that he is actually insoluble in water. And that being the case, being such a lonely person, he's unreactive, he doesn't react with anybody. Okay, and so that being the case, the chemical properties of noble gases is that they are unreactive. Shouldn't be too hard for you guys to remember. The reason why they are unreactive is really because they have either a duplet or octet. Full electronic structure, okay? Configuration, full electronic configuration, okay, that would be a better word. Because they have attained full electronic configuration, they are generally unreactive. Now, in this very simple chapter, right, all you need to do is just remember some these physical properties and chemical properties, and it will be very important for you guys to also remember the uses, okay? The uses of the various noble gases. So, I'm going to share with you how to remember some of them, okay? So in this case here, the noble gases, one way to remember is that helium. Now, helium is used in airship balloons. If you need to remember this, just remember the Hindenburg incident. Okay, in this case here, the Hindenburg incident is actually a weather balloon. It was originally filled with hydrogen and it floats into the sky carrying people and goods. But what happened one day is that it met with a terrible accident. Everything gets combusted because hydrogen is flammable, and as a result of this, they now change it to using helium. Maybe helium, okay, is used to put airship balloons. Now, neon are used to fill neon lights. Okay, it's also used for advertising. Okay, so neon lights for advertising. You need it to be catchy, you need it to be bright. Neon is the color you want to use. Argon, okay? Argon is actually used to fill, it's actually the gas, it's actually the inert, okay? Inert means it's not reactive. Inert gas filled in light bulbs that uses tungsten. Tungsten, that's TUN. Okay, TUNG. Filament. Now, what happened is because argon is very inert, okay, when it's filled and changed the light bulb, right, what happens is that it prevents, okay, the oxidation of your tungsten filament at heat, under hot temperature. Okay, next. Okay, so what happened is, in this case here, you don't exactly need to remember the use of krypton. Another very useful one, okay, would actually be your xenon. Now, xenon is actually the gas, okay, used to fill your headlight lamps. Okay, this is actually the two front lights in front of your car. If it helps you to remember, just visualize a car with two X in the place of those headlights. So this is a very short chapter. Do remember the uses. Remember a few of them. If you can't remember all, hopefully at least 3 will be very useful. Okay, and the physical properties and chemical properties and the reason, okay, why your noble gases are unreactive. It's simply because they have attained a full electronic configuration, either the case of a duplet structure for the case of your helium and the octet structure for the rest. Okay, that is all for this chapter. Thank you.